So, without further ado, I'll start to explain to you the presentations. So each session will run for 45 minutes. We ask all participants to be muted to enable speakers to present without interruptions. And at the end of each presentation, we will have 10 minutes of Q&A at the end, and the sessions will be recorded and it will be made available to all attendees after the event. I'll start to introduce the first speaker, Mr. Bas Dijkstra, who will be talking about solving the integration testing puzzle with contract testing. Mr. Bas, would you please unmute yourself?
Hello, good morning, or good afternoon, good evening, wherever you are. Hello, hello. First of all, thank you so much for having me, and thank you for that wonderful introduction. I'm looking forward to seeing what the QA evolution community is going to bring and what it's going to look like in the months and years to come. So I'm quite excited about that. Shall I just get started?
Yes, please.
Awesome. Let me take over the screen sharing.
Yes.
Could you please very quickly confirm that you can see my screen now?
Yes.
Awesome.
Perfect.
Let's get started then. So, again, thank you for having me, and thank you for taking the time out of your day to join this session. My name is Bas Dijkstra. I'm a test automation consultant trainer from the Netherlands. And what I'll be talking to you about today is, well, as you can see on the screen, solving the integration testing puzzle with contract testing. First of all, quick disclaimer, contract testing, something you do next to what people call functional testing of APIs. It's not something that replaces your existing API testing or automation efforts. It's something you do because it's meant to provide an answer to a different question, actually. But we'll get into that. So contract testing, the term contract testing has been around for a long time, really. But it's only really in recent years that we've seen it becoming more popular, more people getting interested in contract testing, more people asking questions about contract testing, more people writing, speaking, blogging about contract testing. And that's because in recent years, software systems have become ever more distributed. So we used to have lots of monolithic systems where there wasn't really a whole lot of parallel development and componentized architecture in place. But we've seen more and more, we've seen software systems becoming more and more distributed. Microservices is just one of the many trends in that area. So people tend to equate contract testing with microservices, but it's really, it works. It provides lots of value, even if your system is not based on a microservices architecture. So as development becomes, as systems become more and more distributed, getting an answer to this question, are all individual components and services able to communicate with one another, becomes more and more difficult because you have different teams, different departments, maybe even different organizations working on different parts of a system. They all do development in their own nice little bubble. They do deployments. They do, hopefully they do a little bit of testing too. I'm just going to assume that it's not always the case, but I'm going to assume that they do. But at some point, you need someone who can give you need, or something, or a practice, or a process, or a person that helps you get an answer to this question. Are all these individual components and services, are they also able to communicate with one another? So for example, and you'll see that in the live demo that I've got that I'll be running later on in this session. So let's, for example, take the hypothetical situation of a web shop where I've got a service or a component that's responsible for managing data around addresses. So streets, house numbers, whatever. That's managed by and developed and deployed and managed by an address provider team. And hopefully they do some testing. So they invoke their service, they do API testing, functional performance, any kind of API testing really, against that service to make sure that that service works according to their interpretation of the specifications. So hopefully they do this. The challenge with distributed systems is that it's not the address provider team that's going to consume that address provider service. It's going to be other kinds of services. And if you have distributed software development, those services, those consumers might be developed in different teams, different departments, maybe even different organizations. So in this hypothetical example, we have a customer consumer and an order consumer. So two different consumers that both rely on the same provider. So they both invoke the provider, each with their own set of requests and each with their own set of expectations about the behavior of that provider. And of course, there might be a difference between what these consumers expect about the behavior of the provider and what the address provider actually does. And that's where things get interesting. So, for example, maybe they expect a type field to have a value of delivery, but the address provider doesn't return it. Or maybe they expect delivery to be formatted like this, but it's formatted like this. Or maybe they expect dates and times are always very, very interesting. Maybe they expect dates and times fields to look like this, but they actually look like this. And if you have multiple consumers, another very interesting situation is where one consumer expects something different from another consumer. So maybe for a certain operation, consumer one expects a response with an HTTP status code 200, and the other consumer expects a 201. Maybe one consumer expects the date to look like this, and the other expects the date to look like this. This is why we do integration testing. The traditional way in which we do integration testing is basically an everything at once approach. So we frantically try to get all these systems into some kind of testing environment in the right state with the right data. And maybe, hopefully, that gives an accurate representation of what the actual system is going to look like. I've seen teams, organizations that have dedicated people or sometimes even dedicated teams whose only responsibility is to make sure that everything can be tested, that everything can be integration tested. This is a lot of work. It's also very frustrating work. It's not fun. It always happens at the very last moment. So we need something else. And that's where contract testing comes into play. So contract testing is different from, let's call it, traditional integration testing in two ways. First of all, instead of focusing on everything at once, contract-based integration testing focuses solely on the integration of individual pairs of a consumer and a provider, which means that instead of verifying that A, B, C, and D work together, it checks that A is able to communicate with B, B is able to communicate with C, and B is able to communicate with D. So it breaks down that puzzle into smaller pieces. And we all know smaller pieces are easier to manage. So that's one difference. The other one, and I think that's maybe even more important, is that traditional integration end-to-end testing is synchronous, meaning that if we want to test the integration between different components, they need to be in the same environment at the same point in time, because they're actually going to exchange requests and responses. That's what I mean by synchronous. So at some point in time, different components that talk to one another need to be in the same test environment. Contract-based testing is asynchronous, meaning that, sure, there's still work to do for both the consumer and the provider, but they can do that as part of their own development cycle, which means that at no point during the contract testing cycle do the consumer and the provider actually have to talk to one another, because they communicate through the contracts. The biggest benefit of this is that both the consumer and the provider can do their part of the contract testing cycle as part of their own local development and build pipeline, which means that it can be done way earlier in the process. And we all know the earlier we can do our testing, the cheaper it the quicker it's going to be, the faster we are going to get feedback, and probably also the cheaper it's going to be to address and fix any issues. So in other words, I don't really like the term, but I've seen it thrown around a lot. Contract testing is a great way to shift left your integration testing efforts. What people tend to forget when we talk about contract testing is that there's actually a couple of different approaches to contract testing. A lot of people immediately conflate contract testing with Pact. Pact is the most popular contract testing tool out there. It's a fantastic tool, absolutely, but Pact is a consumer-driven contract testing tool, and which is only one of 3 approaches to contract testing. With consumer-driven contract testing, it's the consumer who calls the shots, basically. It's the consumer who's in the lead. The consumer writes down expectations about the behavior of the provider in a contract, hands that over to the provider, and it's then the responsibility of the provider to demonstrate that they can meet all of the expectations that are written in the contract by the consumer. Consumer-driven contract testing is great. It also has a couple of downsides. We'll get to that later on. But it's only one of 3 different approaches. The second one is, well, if you have consumer-driven, then you probably also have provider-driven. Yes. I don't really see a lot of people talking about it, because it's not really testing. It's basically the provider telling the consumers, this is what I do, deal with it. There's no real conversation. There's no feedback loop. There's no discussion. It's really very unidirectional, basically. This is what public APIs do. They specify, this is what I do. Here's my contract, or basically my API specification. That's it. And the third approach to contract testing is a fairly new one, and that's called bidirectional contract testing. In bidirectional contract testing, if time allows, I'll hope to tell you a little bit more about that, and maybe show it to you. In bidirectional contract testing, the consumer and the provider are equals, so they both present their own contract, their own way of, for the consumer, it's this is what I expect. For the provider, this is what I do. And there's an independent, trusted third party that matches the consumer contract with the provider contract to see if there are any mismatches. So those are the 3 fundamental approaches to contract testing. If you're going to think about implementing contract testing, please do me a favor, and instead of just trying to throw Pact at the problem and see if it sticks, think about what would be the best approach for us. And you can even say, well, for one integration, I'm choosing bidirectional, whereas for another one, I'm doing provider-driven, and then I'm doing consumer-driven for some other integrations. So you can vary that from one integration to the next. But it should be the first question that you think about when you start thinking about contract testing, about what type of contract testing really fits my situation. the best. I've written down something about different approaches to contract testing, their pros and cons on my blog. By all means, do check it out. I'll send the slides to the organization. I'm not sure if and how they are going to distribute them, but I will send them so you have the links to that. I want to talk about consumer-driven contract testing and about Pact in a little bit more detail now. So consumer-driven contract testing, or CDCT, is a technique supported by tools that helps you formalize the expectations about that the consumer has about the behavior of the provider in contracts. The tools, of which again Pact is the most popular one, help you to automatically generate the contracts and automatically verify that the providers meet the expectations. Big benefit for consumer-driven contract testing is that providers can develop a refactor without fear, which means that as long as they meet the expectations in the contracts, they can pretty much do whatever they want. Add new features, refactor their code, upgrade frameworks, completely rewrite the service. They can do that without the fear of breaking something on the consumer side because they've got the contracts. And of course, for the consumers, it's a great way to build and retain trust in, well, is my provider I know something's happening. We don't really talk to the provider team, but how do we know that they're not accidentally breaking something? Well, because you can see the verification results from the providers. So it's a way to build trust in the providers too. So there are a couple of consumer-driven contract testing tools. I mentioned Pact, which is with notable distance the most popular tool. The biggest benefit, I think, of Pact is that it's available for so many different languages. So you see some of them listed on the screen here. And the nice thing about Pact is that if your consumer is written in JavaScript and your provider is written in Java or Ruby or Go or C#, it doesn't really matter because the contracts can be exchanged between consumers and providers written in different languages, which means that you can also easily use it for, is my front end able to communicate with my backend? So those will typically be written in different languages. Your front end in JavaScript, in some flavor of JavaScript, and your backend in, well, whatever your backend language is. Documentation, docs.pact.io is great. Check it out. The only other consumer-driven contract testing tool I know of, I haven't used it, is Spring Cloud Contract. It's undoubtedly a fantastic tool. I don't know. I've not used it. The biggest downside, I think, is, and you probably guessed that from the name, is that it really only applies to Java, and more specifically, it only really works with services, with components that are built using Spring. So if all you do is Spring Boot services, Spring Cloud Contract is definitely a contender. If you use other languages and frameworks, you probably want to have a look at Pact if you're looking at implementing or doing a proof of concept with consumer-driven contract testing. So how does Pact work? This is an image. This is also why this image looks the best in the entire slide deck, because I stole that one from someone else. It all starts with the consumer. The consumer writes code, writes tests that do two things. Those tests have two purposes. They generate the contract, and they are used, of course, to check the implementation of the consumer itself. So those would typically be what people call unit tests. So and what Pact does is, from that contract, So the tests generate the contract and immediately also generate a mock provider, which the consumer can then use to test their own implementation. That contract is then passed to a provider, and Pact can also be used on the provider side to replay all of the interactions that the consumer has written down in the contract against an actual real running instance of the provider, and verify that the actual real responses from the provider meet the expectations that are written down in the contract. I'll do a quick demo in a moment. So that hopefully makes it come much more alive than this image could ever do. Basically, what the flow looks like, of course, we also need a man in the middle. We need an entity, a mechanism to distribute and version the contracts, as well as match them with verification results. That's what the Pact broker does. So a Pact broker is a library, a repository actually, for contracts and verification results. There are two flavors of the Pact broker. We have Pact Flow, which is a commercial software as a service product with a free plan. So it's all web-based. And then you have an open source Pact broker, which is basically just a Docker image, which you can deploy and run on your own hardware, in your own cloud, on your own infrastructure. Both Pact Flow and the open source Pact broker support consumer-driven contract testing. So everything you'll see in at least the first part of the demo can be done. I'm using Pact Flow because it's just a little bit easier to show you. But everything that I'm showing in that first part of the demo can be done with the open source Pact broker as well. So what the flow looks like is, it all starts, again, it's consumer-driven contract testing, so everything starts with the consumer. The consumer generates and publishes a contract to the Pact broker. The provider downloads the contract, verifies that they meet the expectations that are written down in the contract by the consumer, publishes the verification results, and then both the consumer and the provider can query the Pact broker and see, are there any known integration issues? Is it safe for me to release a next version into whatever kind of environment? And that can be your production environment. You do that. I'm not going to demo. That's not part of the demo, but in the whole Pact ecosystem, there's a tool called Can I Deploy, which does exactly this. It queries the Pact broker to see if there are any known integration issues and whether or not it's safe to deploy into whatever environment it is that you want to deploy to. So let's have a look at what this looks like in practice. I've got a project here with I am in, let me quickly go back to, it doesn't really matter all that much. So in this makes it even easier in the longer term. In this project, we've got our two consumers and our address provider. There's also a payment provider, which I'll talk about a little bit later on. These order consumers have expectations about how the address provider works, or should work, actually. Pact helps you to write down those contracts, formalize those expectations in a contract. What that looks like in my tests is, the problem is, the downside is, for some people, you actually need to write tests, but we're testers, so we're fine with that. So for example, if I want to, let's say I want to define the expectations for when I retrieve an existing address ID, which means I do an HTTP GET to the address provider, and I expect data to be returned because the address ID that I'm sending exists. What I'm expressing here is the shape of the response. So I expect an address type to be there, and that should be a string. I expect the street to be present in the response body, should be a string. A house number, that should be an integer, and so on. And I'm also expecting an ID field that should be a UUID, which basically means it should be a string, but not just any string, but a string that matches a specific regular expression. And so I'm expecting the body to look like that, and I also expect the HTTP status code to be equal to 200. There's also expectations about different types of interactions. So what happens when the address ID does not exist? Well, the only real expectation I've got in that situation is that I want the provider to respond with a 404. And finally, if the address ID is incorrectly formatted, I expect it to return a status code 200. So if I run the tests on the consumer side, on the customer consumer side, it will test the implementation of the customer consumer, because I've written tests that use this, and they invoke a mocked version of the actual provider and generate a contract. And they will, as I said, generate the contract. Just to save some time, I'm going to see, is the pact still there? It is. That saves me running the tests. Awesome. So I've got a contract now, which is generated on the consumer side. It is right here. There you go. This is the contract that contains all of the interactions and the expectations about how the provider should behave. Just to be sure, I'm going to do the exact same thing for the order consumer. So generate a contract there. And the next thing I am going to do is, after this one is done, so this does the exact same thing for the order. Actually, the order consumer has the exact same expectations here, so not a lot of things to worry about. The next thing that I'm going to do is I'm going to publish the contracts. So I am going to, it's a little bit slower than I hoped. But after these tests have finished running, I'm going to publish the contract. There we go. It's not going to run all the tests. It's really only running the, there we, oh, come on. Yes. And I'm going to do the exact same thing for the customer consumer. So this publishes the contracts that I generated to Pactflow. This is Pactflow. Right now it's empty, so there's no integrations, no contracts, no nothing. But let's quickly check if it's done. It is done. If I hit refresh, I'll see that there are a couple of integrations here. So I've got a contract between the customer consumer and the address provider that are, as of now, unverified. So the consumer has uploaded a contract that has not been verified. I can even look into the contract and see all the different interactions and the expectations around those interactions. But right now, the consumer has done their part of the job. So they've generated and published the contract. Now let's go to the provider. When I run the tests on the provider side, so that's this one, it's going to pull all the relevant contracts from the broker, replay all the interactions in all of the contracts from let me quickly look up, because this is it. So when I run the tests, it's going to pull the contracts from the broker. It's going to replay all the interactions against an actual running instance of the provider. And it's going to publish the verification results back to the broker. It doesn't do so by default. I need to actually tell it. That's why I said Pact provided publish results is true. That overrides the default setting of not publishing the verification results. But it's so I like to live a little bit dangerously here, and I'm going to just immediately publish the results so we can see whether or not the actual provider implementation that I've got in here is able to meet all of the expectations from the consumers. It's a lot of output, but the build is successful. And if I refresh here, I can see, let's go to the overview, that we have a success, which means that the current implementation, so version 100 of our provider, is able to meet the expectations of consumer version 100. So those two versions are compatible, which we can also see in the Pact matrix for this integration. I've got a consumer version, I've got a provider version, and those are compatible. Now, say, for example, if my customer consumer updates some expectations. So, for example, if instead of a success for a successful delete, instead of a 204, it expects a 200. This is my customer consumer. I'm generating a new contract here because I've got an updated expectation. And let me quickly then also update the actual version of the project to 101 or one. It's not it's a new release. It's not just a bug fix. So 110. So a new version of a customer consumer with a new set of expectations, basically a new version of the contract. So my tests still, let's publish that to the broker. So this is a new version of the contract for the customer consumer, associated with customer consumer version 110, which if we refresh again, we can see in our matrix. So we have, this one is still retained, but now we've got a new version, a new consumer version with a new contract that was published just a few seconds ago, which is as of yet unverified. Let's go to the address provider again and run those tests again for the same provider version, because that hasn't changed. And let's see what happens if I try to replay the expectations in that contract in against provider version 100. So the tests are going to be run again. The provider's again going to pull all the relevant contracts from the broker, replay the interactions against an actual instance of the provider, and publish the verification results back to the broker. As you probably can imagine, this is going to generate a problem because the address provider is unable to meet all of the expectations in all of the contracts, because there's an updated expectation in the customer consumer contract, which the current version of the provider cannot fulfill. As we can see, if I refresh here again, then Pact will also show, well, there's a problem here. And we can even have a look at what the exact problem is. It's this specific interaction where, well, the consumer expected the status 200, but the provider actually returned a 204. So we can see now in this matrix that consumer version 1.0.0 and provider version 1.0.0 are still compatible, but consumer version 1.1.0 introduces a change that potentially breaks the integration. So, and this is where a conversation should start between the customer consumer and the address provider about, how are we going to resolve this? It's not pointing fingers. Pact is not pointing fingers at, oh, well, it's the customer or the consumer who should change their implementation or their expectations, or it's the provider who needs to change their implementation. It's just signaling, well, in this version, there's an issue, there's an integration issue, a potential integration issue between this consumer and this provider. All right. All of the code that you've seen is available at GitHub, so you can download it, clone it, and play around with it if you want to. So this is consumer-driven contract testing. And with consumer-driven, there are a couple of challenges. I've listed some of them here. So it's not a very good way to test the implementation details of a provider. That should be done by the provider development team. You should not, it's a very bad idea actually to use contract testing to make up for the lack of testing that the provider team does. So please don't do that. Just tell the provider team to do their own testing. It also doesn't really work well for public APIs because there's no chance that they are going to listen to the consumers about, oh, well, I want this specific behavior I want you to respond to this specific operation, this specific. With public APIs, it's typically, well, this is what I do, deal with it. So consumer-driven contract testing, because there is no opportunity for discussion, there's no feedback loop. Consumer-driven contract testing doesn't really work well. Another problem, which is not on this slide, but it's actually a big challenge, is that it's often kind of hard to get testers involved in contract testing because, as you've probably seen, using Pact for consumer-driven contract testing is pretty closely tied to the code and to the implementation of your consumer and your provider. And unfortunately, for a lot of testers, that's still a big step, a big hurdle to actually get involved in the code and work so close to the code. So it's typically in a lot of organizations and a lot of teams, developers that start to do this. But I'm sure they could definitely benefit from testers who can have a conversation and work together with them to make this even better, to actually think of, oh, but did we think about this situation? Did we think about that? So I think it's very important for testers to also understand this. But the reality is, for a lot of testers, this is a big step, actually diving into the code, looking at the code, and working together with the developers to make this happen. There's other things that consumer-driven contract testing does not do or does not do very well. And you can find those on the Pact website because they've been very open and upfront about this is what we do well and this is what we don't do as well. To address some of those issues, the people behind Pact came up with a new way to do contract testing, and that's called bidirectional contract testing. I referred to that a little bit earlier. Big disclaimer, bidirectional contract testing only works with Pact flow. So what I'm going to show you, because I see I've got about 7 minutes left or so until we start. Oh, no, we are... Is it true? We are already in Q&A time, right? At least
okay, go ahead, take your time.
No, I want to reserve a couple of minutes for Q&A. So, so I'll be quick. I'll just not do the demo then, unfortunately. But there's another way to do this, and that's called bidirectional contract contract testing, where instead of this is the consumer-driven contract testing flow that we saw, where the consumer generates a contract, the provider has the responsibility of verifying compliance and telling it, well, this is what I do. So here's where I'm compatible. Here is where we are not compatible. The bidirectional contract testing flow is simpler because it's both the other way. So it's both the consumer and the provider who publish their own version of a contract. So the consumer generates a contract of their own. It can be a contract generated by Pact, but there's also different ways to do that, easier ways to do that. And the provider also publishes their provider contract, which right now can only be an open API specification. The good news is most providers will have an open API specification. So for them, it's really easy to start getting involved here because they pretty much the only thing they need to do is publish the contract they already have to the broker. Then it's the broker who checks for compatibility. So that's logic, that's features built into the broker. And again, right now, that's only in Pact flow. So you cannot do that with the open source Pact broker. And after Pact flow is done doing that, again, as before, both the consumer and the provider can check, well, are there any compatibility issues? Are there any known integration issues? So I've provided some links here. So by all means, take a quick screenshot or just know where to Google for bidirectional contract testing. You'll probably see a couple of these links rating pretty high in Google or Bing or whatever kind of search it is that you're using. And again, I want to be respectful of the time and also leave some time for the next, leave enough time for the next for you to introduce the next speaker. So let's go for Q&A if there's any.
Yes, thank you so much, Bas. It was really, really a great presentation. I really liked the demo at the end, by the way. So let's begin.
Thank you.
Yeah, I already have some questions which were sent. So let's begin with the first question, which was sent by Sabri. He's asking, how does contract testing handle issues related to API changes and versioning?
I hope I addressed that well enough in the demo because you can see in the matrix in Pact, it stores not only contracts but also versions of contracts, and rather it associates versions of contracts with versions of your consumer and your provider. So it should be if you do this properly and diligently, you should be able to pretty quickly get a feeling for, oh, but this change introduced something that that caused a potential integration issue. So if you do this diligent, and I've even seen teams do this, associate not just a release version, as I did in the demo, with what they publish, but also commit hashes. So you can not just say, well, oh, there's a problem when a problem was introduced when we stepped from this to this version, but a problem was introduced in this specific commit. And so you can get even more granular with what versions are compatible and what versions are, with what versions did the problem start.
Yes. So we are having a question from Jasper. Is asking, is it possible for a provider to be a consumer in a different situation, integration? So the names you used, like customer, consumer are example names just for clarity in this specific situation?
Yep.
Mm-hmm.
Yes, they can actually. If you look at the all the way back here, where is it again? There it is. For example, this service B, it can be a provider to A and a consumer to C. So it's you'll actually see that happening a lot, where services are either they just very simple pass through components, or they do some kind of transformation and then passing along to, and Pact definitely allows for that. So that's definitely something that's supported.
Mm-hmm. Great. Another question. So, what are the most common mistakes or misconceptions that teams make when adopting contract testing?
Ooh, how many minutes do have we got left?
Take your time,
it,
please.
no, we have no. I don't. I want to be again. You have a schedule, and I want to stick to that.
Okay, take your time. We have enough time.
Okay, so that's good to know. So it's not a silver bullet. It is and what people tend to underestimate is not the technical the technology is never really the problem. It's typically the time it takes to get everybody on board with contract, and especially provider teams, because they tend to be a little bit hesitant. Also, because there's but we've got our own tests, and now we've also got to take into account all of these contracts sent to us by all of these consumers. So it's not really a mistake, but I see some people underestimating that. And another one is that, especially if you do consumer-driven contract testing, it'll take quite a bit of work to get it done. Implementing Pact is, it takes time and effort. You need to start writing tests, which means you need to make sure that your code is actually testable. And that takes time and effort. So you need to, if you want to do this properly, you need to not just, throw a tool at the problem. You need to start thinking a little bit differently about how are we actually developing our services? How are we deploying? What does our deployment pipeline and strategy and schedule looks like? So it is, people sometimes tend to underestimate the effort it takes to get this up and running. This is also why, again, the people behind Pact came up with bidirectional contract testing. That has some downsides too, because you can be less specific about what it exactly is that you want from a provider, for example. But the amount of effort it takes to implement it and to get started with contract testing is way lower, because it leverages existing technology and existing tests, instead of you having to introduce a completely new tool and a completely new set of tests. Oops. So it's not really a mistake, but rather it's what people sometimes forget when they start thinking about and start implementing contract testing.
Thank you so much, Bas. I really enjoyed the presentation. I hope all the attendees really enjoyed it.
I hope so too. Thank you very much for having me. If there are any questions at some point, by all means, send an email. My email address is on screen right now. Connect with me on LinkedIn. I'd be more than happy to continue the conversation. I'll leave it at that, I think, also regarding the time. Again, thank you so much for having me, people, organizers. Participant, thank you so much for taking the time out of your day to attend and to listen. And I hope you'll really enjoy the rest of the day and the days to come as well. So thank you very much.
Thank you so much. Goodbye, Bas.
Bye-bye.